In addition to electrochemical cells, we also have processes called electrolytic processes. Now, these processes are not spontaneous, so they're exactly the opposite of the electrochemical cell. So the electrolytic cell, completely opposite of the electrochemical cell. They're not spontaneous, so they have a negative cell potential, and they also have a positive delta G. You can actually take an electrochemical cell, flip it completely, oxidation becomes reduction, reduction becomes oxidation, and you then have an electrolytic process. An electrolytic process is something that you actually send current through to make the reaction go. So the reaction does not go on its own. It's forced to go by sending a current through the whole cell. So the purpose of an electrolytic cell is not to generate current, rather it's usually to perform a specific chemical reaction. In the case of electrolysis of water, you're trying to create oxygen and hydrogen. Now, water decomposing is not a spontaneous reaction. So water doesn't typically break down via oxidation reduction. So electrolysis of water is not a spontaneous reaction. And if we take the voltages there and add the voltages up, we do get a net negative voltage. That net negative voltage then would not allow water to break up into hydrogen and oxygen spontaneously. So this is actually used for the production of oxygen and the production of hydrogen. Another function of electrolysis is to electroplate metals. So if you wanted to put, for example, silver onto a particular metal, you would use electrolysis to do that. So you would have an anode reaction and a cathode reaction, and then you would have a solution of the material that you're trying to plate. So in this case it would be silver ion. You would have an anode made of the plating material, which of course is the silver, and then the cathode would be the object that you're plating, and then of course you need a battery or some source of current, and so you can actually cause the silver metal to be plated onto the cathode. So we have done this in the past with spoons. You can actually plate silver right on top of a spoon, but again you're sending current through. So this is an electrolysis apparatus here. So you're not producing current, rather you're using current to do some sort of particular job, or some kind of a chemical reaction is being made to take place. Now we can calculate how long it takes to plate. We can also calculate how much will be plated. So we're going to go through a mathematical manipulation here to show you that you can actually calculate how long it takes to plate a particular metal, and we're using silver here since we've been discussing silver. So there's our silver reaction. You literally start by first converting the grams of silver that you want to plate into moles. So that 107.87 is simply the molar mass of silver. You look at the balanced equation, and for every 1 mole of electrons being taken up there, it's a mole of silver reacting. And then you should recognize 96,485, that's Faraday's constant, and that's the number of coulombs per mole of electrons. And then last but not least, in the question there it says 20 amp current. An amp is actually a coulomb per second. So you can actually use that 20 amps, 20 coulombs per second, as a conversion factor. Notice the coulombs there drop out and you're left with the total number of seconds. So it would take 2.2 times 10 to the second seconds for the 5 grams of silver to be plated. Now we could reverse this whole process, starting with the time, using the amps, using Faraday's constant, the moles, and the molar mass, and we could actually go backwards then and calculate how much silver metal would be actually plated on there. So this is typically what's done in an electrolytic calculation.